Welcome to the Michelin Technical Series of videos and presentations. At Michelin, our prime responsibility toward our customers is to meet their mobility requirements by providing them with safe, innovative products and services capable of satisfying their present and future expectations. Michelin is committed to safety when fitting tubeless radial tires. This video's focus is on the protected valve wheel assemblies commonly found on buses, coaches, and trucks fitted with disc brakes. We will demonstrate how to properly mount tires on this type of wheel using manual mounting levers. It is highly recommended that you first watch the tubeless radial truck tire safety video, which is part of this series. We are confident that if you follow the best practices for the protected valve assembly mentioned in this video, they will assist you with proper tire fitment, but more importantly, provide a safe working environment for you and your employees. The protected valve wheel was created to prevent the valve stem from being destroyed or damaged by the brake caliper. Before the use of disc brakes, this generally was not an issue because the brake drum rotated with the tire and wheel assembly. With disc brakes, the wheel must rotate around the brake caliper, and the clearance between the two components is extremely tight. If a conventional wheel were used, the valve stem could become damaged or possibly shear off. If an object got inside the wheel or the valve stem was bent, this could lead to a rapid loss of air. The protected valve wheel eliminates this interference and also protects the rubber grommet or air seal by shielding it from the heat created from the vehicle's braking system. To provide these benefits, the wheel had to be redesigned with a hump or raised area on the bead seat closest to the disc face. This configuration allows the valve stem to be installed externally and away from the brake caliper and eliminated the chance of accidental deflation. This change in wheel construction creates a new challenge for tire fitters. The conventional method of using a slide hammer to push the bead down does not supply sufficient enough force to get past the hump in the wheel. The bead on the disc side must be pushed over this hump in order to demount the tire, which will require a special tool and procedure. A special rounded base valve stem is also required to prevent possible bead damage during the dismounting process. A standard valve stem with a raised hexagonal base can cause interference when the bead is pushed over the protected valve hump in the wheel. In order to push the bead down below the raised hump and over the rounded base valve stem, a special tool is required to do the job properly and, above all, safely. In addition to the special tool, let's make sure we have all the tools to do the job right. Most of the tools are the same tools used for the conventional tubeless wheels and tires. They include a slide hammer or bead breaker, as it is sometimes referred to, the proper tire levers, a new rounded base truck-style valve stem sized for a 9.7 mm hole, the proper sized wrench for installing the valve stem, a mat or mounting frame to protect the disc face from getting scratched, a pair of bead keepers. A pair of locking pliers or small clamp can be substituted if you do not have special designed bead keepers. Vegetable-based tire lubricant paste, Michelin Tiger Grease, works excellent for this procedure. A clean paintbrush can be used to apply lubricant to the tire and wheel. A vegetable-based liquid tire lubricant can be very helpful for tire wheel assemblies that have been in service for a long period or have been exposed to prolonged brake heat. Michelin Tiger Grease can be diluted with water for this purpose. A wire brush for cleaning any corrosion, old tire lubricant, or rubber buildup from the wheel. A can of quick drying spray primer for coating any exposed metal on the wheel. As mentioned earlier, you will need a special bead braking device. Your Michelin dealer or Michelin sales representative can assist you with purchase information for this tool. Now that we have all the right tools and our technician is wearing the proper safety gear, let's go to work. Start by positioning the wheel with the disc side facing up. Remove the valve core and fully deflate the tire. Once deflated, run a wire down the valve stem to check for blockage. Apply a generous amount of vegetable-based liquid tire lubricant between the tire and the rim flange. The space between the tire and the rim flange forms a well for the lubricant and will allow it to flow between the bead and the wheel during the unseating process. This will make it easier to dismount and help prevent bead damage. Warning: only use clean vegetable-based lubricants. Never use motor oil, diesel fuel, antifreeze, or other substances that may contain petroleum distillates to mount and demount tires. These products can break down the rubber, causing it to swell and soften, resulting in permanent damage to the bead. These products can often accelerate corrosion to the wheel. In order to allow the liquid tire lubricant to work its way around the bead, it is helpful to begin the bead unseating with the slide hammer prior to using the special tool. Since this tool is capable of impacting with great force, it should be checked regularly for safe operating condition. The end can get curled over and form sharp edges over time, which can damage the bead when striking force is applied. If burrs or sharp edges are present, file them smooth before using. Work the slide hammer around the circumference of the bead, applying moderate downward force on the tool. Once you have created a small opening for the lubricant flow, the special tool can now be used. Apply additional lubricant if necessary. Position the special bead unseating tool on the wheel and ensure it is fully engaged to the disc face. Start the wedge moving downward to engage the area between the rim flange and the tire bead by turning the screw handle in a clockwise direction. As you turn the screw, the bead of the tire will start to move away from the rim flange towards the raised hump of the protected valve wheel. As with conventional style wheels, beads can become stuck to the rim surface, making them difficult to unseat. The main cause for this sticking is prolonged exposure to excessive brake heat. Michelin studies have shown that brake heat bead temperatures that exceed 121 degrees Celsius for extended periods can cause permanent rubber degradation. The use of improper lubricants during the initial mounting can also cause the tire to stick to the wheel when it's time to dismount. If the bead is not lowering evenly around the circumference of the tire, it may be necessary to break down the bead using several steps. If this occurs, loosen the screw by turning it counterclockwise. Reposition the tool and repeat the unseating process in another area. Repeat this process as many times as necessary to fully push the bead below the raised hump. Use additional caution when working the bead over the valve stem area. Apply additional lubricant during these steps to assist with unseating the bead. A slide hammer can be used to assist with the unseating. Continue to use liberal amounts of liquid lubricant. Once the bead is pushed completely below the protected valve hump, the tool can be removed. Flip the tire and wheel assembly over so the disc side is facing down. Use a mounting frame or mat to protect the face of the wheel. The unseating procedure can now be repeated on the bead, which is opposite the protected valve hump. Since this side of the wheel is the same as a conventional wheel, a slide hammer can be used in lieu of the special tool to speed up the process. Remember to apply lubricant and work the bead down evenly. Once both beads are completely unseated, additional lubricant should be added to any dry areas of the bead. With the wheel still disc face down, commence removal of the first beads. Using the proper tire levers positioned 10 to 15 centimeters apart, pry the bead over the rim flange by pushing both levers all the way to the opposite rim flange. Remove one of the levers and reinsert it approximately 15 centimeters from its original position. Make sure you insert the lever fully so that the tip of the lever is below the bead toe. Failure to do so can damage the bead and make it unserviceable. Repeat this process until the first bead is completely over the rim flange. Flip the tire and wheel assembly over so the disc side of the wheel is facing up. You will now use the two levers together. We will refer to them as lever number 1 and lever number 2. Insert the notched end of lever number 1 between the bead and the wheel, positioning it perpendicular to the ground. Use lever number 2 to lift the wheel out of the tire by inserting the tip into the drop center and pry upward using the tire sidewall as a pivot point. With both lever number 1 and 2 fully engaged to the rim flange, swing the bars away and down from the wheel using the tire sidewall as a pivot point. This action should force the lower rim flange up and out of the tire's second bead. We will now demonstrate the proper technique for fitting the tire using a protected valve wheel. A proper mounting technique will ensure concentric seating of the beads to the wheel and minimize the chance of bead damage. We must start the process with a clean wheel, free of excessive rust, old lubricant, and dirt. Always install a new valve stem with each mount. Remember, the rounded base stem should be used. Start the mounting process by lubricating with generous amounts of tire lubricant to both the tire and the wheel. Michelin Tiger Grease provides premium lubricating properties and is well suited for mounting tires to protected valve wheels. Lubricate the entire surface of the wheel, then apply lubricant to the tire bead from the bead toe to just below the molded rib located above the bead. Once lubricated, position the tire next to the wheel in the vertical position. Align the bead closest to the wheel with the drop center of the wheel. Let the tire fall onto the wheel. Then, place your hands at the 10 o'clock and 2 o'clock positions and push the first bead over the rim flange. A rocking motion usually helps this process. If the first bead does not fully go over the rim flange, use the curved end of the tire lever to finish the process. To mount the second bead, start at the valve stem by pushing the bead down below the rim flange. A set of bead keepers will facilitate the mounting process as it will prevent the bead from walking off as you work it around the wheel circumference. A pair of locking pliers will suffice if bead keepers are unavailable. Using the curved end of the bar, begin prying the second bead over the rim flange, a little at a time. Attempting to pry a large portion of the bead over the flange will cause you to work harder and increase the risk of bead damage. If bead keepers are used, slide the keeper towards the lever each time you pry a section of bead over the flange. Continue this process until the second bead is completely over the flange. The tire is now ready to be inflated. The inflation process is similar to the conventional tubeless radial truck tire, and the same safety precaution should be followed. Remember, a more detailed view of safety requirements, tools, and procedures is available in the tubeless and tube-type mounting videos of this video series. Let's start the inflation process with the disc facing up and the valve core removed. Place the tire wheel assembly on a tire stand to support the protected valve wheel, which will elevate the tire sidewall above the floor. This procedure will help the bead seat evenly. You should avoid airing the tire when it is in the vertical position. The weight of the wheel pushing downward can impair the tire from seating concentrically to the wheel. Warning: do not exceed 5 psi or 0.34 bar when inflating outside a restraining device. Never use flammable chemicals such as ether or propane to seat beads. Once 5 psi or 0.34 bar is reached, screw on a metal valve cap to contain the air in the tire. You can now stand the tire up and roll it into the restraining device. Once in the restraining device, you can remove the metal valve cap and inflate to the normal operating pressure. During the inflation process, always remember to air safe. A. Always use a restraining device. I. Inflate with the valve core removed. R. Remain outside the trajectory zone. S. Safety glasses and shoes should be worn while conducting tire work. A. Air pressure should not exceed the wheel's maximum pressure. F. Feet and hands should never be placed between the tire and restraining device. E. Evacuate air immediately if popping sounds are heard or signs of zipper rupture are present. A rapid air loss caused by a zipper rupture or bad wheel can be a dangerous situation. Listen and observe. Once the operating pressure is reached and there are no visual bulges or undulations in the sidewall, the valve core can be installed. Once installed, top off air pressure to recommended value if necessary. This concludes our presentation on protected valve wheel assemblies. We hope this video allows you to work smarter and safer. Thanks for watching.
Michelin, a better way forward.